Hello everyone, and today I'm going to be showing you how to do electrolysis of salt water to make copper and chloride or whatever. So first thing you're going to need is a power output. I've got the yellow and black wires of this mains power cable hooked up to a 12 volt 4 amp adapter. Very important that you use adapter and you've got to resist the urge to plug it directly into the wall and put a death cable in here, because while it may look cool for a few seconds, you will probably make something terrible happen. So first step, we're going to get a little beaker here and we're just going to measure out a bit of water. But before we do that, we're going to take some salt. I've got some salt over here, and we're going to mix some salt with the water. The saltier it is, the more conductive it will be. I'm just going to pour a copious amount of salt. This is too much salt. You could probably get away with just using about a teaspoon. I've probably put the equivalent of about 4 tablespoons in just there. So now we're going to stir it around. Normally you should use a glass stir rod when you're doing chemical stuff, because you don't want to contaminate. But right now I'm just using what looks like a glass stir rod but is actually a hot glue stick. Don't do this if you're using other chemicals, because it will dissolve and ruin your chemistry. So now we've got some salt water mixed up. I'm just going to pour some into the beaker here over the carpet. Don't do this at home. Next we're going to pour this little beaker of not very pure but alright salt water into a little glass container here, which for some reason I have lost the name of, and we're just going to measure out a few beakers full. Normally you would do this all precisely with measurements. I can't be bothered, so I'm just going to tip the cup directly in. I'm just going to fill this container up, this little thing up with salt water. We now have a round bottle looking thing of salt water. You don't need a fancy glass thing like this, you can just use a regular cup. Of course though, if you're doing this, you probably don't want to use one that you drink from, because when we continue with this, it is going to make a very toxic substance that you most definitely don't want to ingest. Also, this will produce gases which aren't good for you. One of them being hydrogen, one of them being oxygen, and the other one being, I believe it is chloride gas. So you're going to want to do this in a well ventilated area. I am not in a well ventilated area, but that's okay, because I don't mind. Okay, so now we've got the power live, just to test that the power cable is actually live. We're just going to touch it together real quick here, and as you can see, it is sparking a little bit. It's not very strong sparks. For some reason the output power on my 4 amp supply is not very good at the moment. And then we're just going to lower these terminals in to the container here, and as soon as it makes contact with the salt water, we are going to begin getting an electrolysis reaction. I don't know if you can see this very well. If I bring the terminals close, you can see that there is bubbles coming off of one terminal and a few bubbles, but not very many bubbles, coming off of the other terminal. One of the terminals will produce oxygen, the other will produce hydrogen as the electricity decomposes the water into its core elements. This isn't a great power supply, so this is going very slow. I would recommend using a better power supply than I've got right now if you want this to go a lot faster. However, if you do use a higher amount of power going through here, you're going to want to make sure that the voltage is kept low and the amperage is kept high. And also you're going to need to watch out for it heating up. I have done this before with a very powerful power supply, and the result of that was that the glass got so hot that it would burn you when you touched it, so you don't want to do that. I'm fine with just letting it slowly bubble away here. As you can see, it's very slow. If you let it bubble for long enough, it will sometimes form little bubbles on the surface that you can then light on fire, because it's hydrogen and oxygen gas, so it explodes when you light it on fire, which is very cool. And you can just let this run for as long as you want. If you're using just regular iodized table salt and regular water, and the terminals are copper, important that the terminals are copper for this to make copper chloride. If you use other terminals like steel multi-strand wire or, I don't know, brass, it's going to make different compounds. Also, I believe if you use titanium, it will just produce hydrogen and oxygen gas from the reaction, and it will not erode the terminals. These terminals here that currently look fine, if you were to let this run for long enough with enough power going through it, the result would be that one of the terminals will get completely dissolved into the water and it will get completely eaten up by the electricity flowing out of it. So that's another thing to watch out for. And that's how you make green toxic copper chloride water. If you were to let this run, it would eventually turn all the water green. If you let it run for too long and there's a lot of impurities, it will probably turn brown. And I don't know what you'd use copper chloride for. I can't really think of any uses that are that useful. I'm sure there are uses for it. I tried to make a copper chloride gas grenade when I was about 13, which wasn't very smart, and I let it off underground in a bunker I'd made, but that wasn't great. It doesn't really do anything. It's not that impressive. It was quite useless and a waste of my time. Anyway, thanks for watching and have a nice day. Goodbye.